Infrastructure robustness, suggested by our very own Ruud van der Paas, with the strategic participation of Luca Carloni, who will ask questions, DK Panda, Don Christie, CEO of Catalyst New Zealand, and Ben Mintz from Oak Ridge National Labs. The whole point of a panel is to have a conversation, not to lecture. So don't worry if you are not thinking as an expert. The question is, we have, as I'm reading here, and let's see if I make it a little bit larger. Here we are. So the CrowdStrike bug, which maybe you remember or not, or you can click there. So when these things will happen, should we take it as something that will happen? It's a risk that we need to get used to it. It's like driving a car. Should we accept that cars will crash now and then? So how are we missing something on this? Or could the magic of AI help us? And can we identify at least the worst case scenarios? And can we fix it thanks to AI or something else? Or should we let AI to do it automatically? Are we happy with that? Is this something that we will allow? So the question is literally when an infrastructure is robust enough for us to trust, and we go from there. So let me start with Ruud in the middle.
Okay, thank you. I'll try to answer my own questions. It's an open question. What struck me is that there's a lot of energy and coding and effort spent on security, which is a good thing. But when a system goes down, and especially when it's highly disruptive, we seem to we don't like it, but we seem to accept it. And my question is there any work done to at least minimize it? Nicholas compared it with a car crash. I would say, can we have at least a minimal number of crashes instead of crashing all over the place all the time? Or maybe the outages that we see are indeed about the minimum we can do. This is all under control, this is all happening. I don't have the insight to do it, but I get the feel that it's ignored a bit. And then taking that a step further, what are the scientists doing to help us? Like they're very busy, people in computer science about static analysis. Some friends of mine, they work on static analysis for security again, dynamic analysis. Do we do the same with outages? I don't know. I hope to learn more actually on that here in this panel.
When I invited you to this panel is more thinking about your professional expertise asking questions as a fantastic academic, but also you design processes to develop something, not necessarily infrastructure, but infrastructure is based on chips. So,
and chips are delicate objects to design, which can fail in many different ways. So I'm not an expert in large-scale computing system, but in the small scale of a chip, certainly you can have problems because one bug or one error becomes a complete failure of the whole system. And in my experience, you can design the system in such a way to minimize these occurrences, and so make sure that the system is robust enough. And this is often a case of redundancy, and which is expensive, but it's something you do. You can use, in part, as we mentioned, static approaches analysis, or do some sort of contract-based or interface-based methodologies that provide certain system-level guarantees while you're designing the components, and therefore decouple the design of the component from the design of the system. And in my experience, to the extent that I can speak about those type of systems as complex systems, these can go a long way with respect at avoiding catastrophic failures. But then there is another area for which I always find it difficult, from my perspective, also as an educator, is the fact that sometimes it's the aspect of security, it's the aspect of the malicious attack. So I guess if you ask me to prompt some questions, I would like to ask the fellow panelists here from their perspective of what is that keeps them awake. Is more like the fact that one error in the engineering of the system may lead to a major failure, or is that there is something that has been not thought about that allows an attack. And of course, there is a relationship between. One can say every time you leave a door open or you make a bug, then it makes the system easier to attack. But sometimes maybe that's not the case. So that's what I would like to understand.
So, DK, Professor Panda, I mean, you presented today about Icicle, and I can imagine this as a heterogeneous distributed system that brings a lot of keywords like IoT or edge computing, but everything goes centralized here and there. There could be a lot of interference in the capture of data, and these could be mission-critical systems as well. So what's your position on this?
Yeah, I think in the heterogeneous systems, again, the failures and complexity is much more higher than the homogeneous systems. But at the same time, you also have flexibility to have redundancy. So if really mission critical systems, you can have alternative paths for communication and all, have redundancy. Of course, it will be more expensive, but if it is mission critical, yes, that is the way to proceed, kind of thing. But in general, coming back to your higher level question of the robustness, I think you must have all heard of like predictive maintenance. Like think of like cars and the jet engines and all. I think AI is actually helping there. If you go to any of the airlines, these days they are adopting AI. They are exactly monitoring all the logs of their engines, the major components. So they exactly know what is the probability of this component will be failing. So before that they are replacing. Okay. So in a way, I think AI is helping in those kind of aircrafts and all. Whether it will come down to lower level, of course, it is more expensive and all. I don't think any cars we have seen yet. I mean, cars are still becoming intelligent, but you know, like these days, even the regular cars, like replacement of oils and all those things, it is no longer like the traditional, like 5,000 miles you do or 6,000 miles you do. The car is able to find out like how much wear and tear it has, then it gives you the green, red signals and all, A1, A2 code and all, so you can do that. So I think the field is heading there. You will see in might be a few years more, we'll have to wait. And you will see this kind of the things will be robust enough.
Ben, you are a director of an institute within of the largest national labs of the US. First, can you describe what Intersect is? But I remember looking at systems of systems as part of it, which is what I think that is related to the topic.
Certainly, yeah. So Intersect is an initiative that we got started about 4 years ago. It's an interconnected science ecosystem. So it was designed to build autonomous labs and then interconnect them and then build workflows that cut across all the different labs. And last time I was here, actually down in Wellington, there was discussion about systems of systems, and just to clarify, because there was some confusion about it, all systems of systems is just a group of systems interacting to do something. And this will definitely add some complexity into the infrastructure. And it's really kind of where things are heading. You're no longer kind of building a single system. You're building a system that is going to interact with some other system, which interacts with another system, which may interact with another one. And that level of complexity, the states that can come up with that is very complex. And humans do a pretty good job at understanding a single system, maybe at one system interacting with another, but when you have a whole bunch of those that are connected together, the chances of the failures that you're talking about increase dramatically, because one system may have something that's completely allowable, but it goes to another one and it breaks that, and then that propagates to the next one and the next one. And I think AI can definitely help with that, because AI can kind of ingest and understand all the different types of states and how the interactions occur and help monitor that. And then the question really becomes, how much do we trust AI? Are we going to, so I'll actually distinguish between AI and autonomy. AI is going to make some determination or an idea to do something, but the autonomy is are we going to allow it to do something? And so there's going to be probably a progression. Like I think right now we use it and it gives us answers, and then humans go and do something. At some point, do we get to the trust level that we say, we're going to deploy new software to systems, and as we're deploying it, AI analyzes it and prevents us from deploying it. So the CrowdStrike was a deployment of software that broke stuff. And so maybe that's where we get to, where it just says, nope, stop, this is gonna break something, and it allows people to get ahead of it. And then you've got kind of the full autonomy. Do you allow it in real time to analyze the systems of systems and say, yes, this system is gonna break that, and have the AI actually manage or update something to fix the problem before it even happens? That one's probably going to be harder to get to, because I don't think we want to give the keys to the kingdom to AI to run everything. So there's a lot of complexity there with the whole systems of systems concepts, and I see it when we talk about the workflows is definitely a big part of
we
that.
saw it earlier in the first talk of the afternoon with Alok asking about who wants machine learning to guide your test or something. Don, you are co-owner and managing director of a medium-sized service company, open source company in New Zealand and other countries in the world. But you are at the cold face of what the user and the clients expect. So they just expect stuff to work. How do you can guarantee them that they are robust, and you can give them, I don't know, how many nines to say a metric? So is this something that your company face on a regular basis, or people just complain to you after things fail?
Kia ora. Well, I just have a very trusting face, and I tell them it's going to work, and they're 259s, and they believe me.
Okay, you are funny as well.
No, I was going to go back to the CrowdStrike conversation, because it kind of relates to that, and I'll try not to be too long. I was actually in Brighton in the UK the morning the CrowdStrike failure broke. It was actually Microsoft's central data region in the US that went down 2 hours before CrowdStrike, that took out all the airlines and all the airports that we heard of. And I was waiting for a flight out of Heathrow. I was listening to the commentary, and some of the commentators, computer scientists, the younger generation of commenters were like, this is inevitable, we have no control, everything is on cloud, it's all on Microsoft or AWS, end of story. Some of the more experienced commentators were, we need to move away from homogeneity. It's interesting, actually, CrowdStrike's home kind of region is the central region of Microsoft's infrastructure in the USA. So, you know, to talk about those systems, one thing led to another. The bit of analysis I haven't seen is whether or not the 2-hour central region outage with multiple availability zones was also responsible ultimately for CrowdStrike not doing its release properly. So we are very much about building resilience and redundancy in different ways, obviously applying open source software, but looking a lot more, this is New Zealand, we've heard from our colleagues at Earth Sciences New Zealand about some of the geological and other challenges we face in this country, and we're in a city that was flattened by a huge earthquake in 2011. So that brings us a perspective that is much more about diversification, both physical and from another software level. we deliberately designed our local cloud offering to be multi-region rather than focusing on in multi-availability zones. One of the issues countries like New Zealand are facing is all our big new data centers are in one region. And it becomes a self-perpetuating issue for us, and I think we're not alone in this, as they all start building themselves close to each other for reasons of latency, wanting multiple availability zones, whereas actually we need to change how we think about some of this infrastructure to be much more region-focused and get physical diversity as well as software diversity as well as supplier diversity into the chain. I should also add, this has been a remarkable conference. I feel like the stupidest person in the room because I've learned so much in the last, I learn so much at these conferences every time I come here. But a lot of what you folks are talking about is beyond my comprehension. So thank you for your tolerance.
So Ruth is dying to start to say something.
Oh, no, I was just going to say, as a software person, I always like to blame hardware. But you were too modest, Luca. I don't think the problem is really in the hardware. I've been in the hardware design organization. They tolerated me there for a couple of years, still being a software person. I think it's at a much higher level. Of course, there's the human error, which is really, really hard to prevent. But when you think about it, and again, I really like to compare to security, what we do on security, which is quite a lot these days, and then what we do on these outages. You can't just take the system down to test it. You can test security while the system is running, but you can't just, you could try, but I don't think you get many tries. And that's another complexity that you have to deal with. And what I see is that testing is usually considered to be like a third-class citizen. It's the first thing to be cut. And maybe that should change to start with. Can you maybe just generate really, really idiot inputs to see what the software does to it? That kind of stuff. And again, I think we don't even try. And then, of course, the next step is like, can you get tools? What you do for static analysis? Can you actually analyze a code and see, like the CrowdStrike is a good example. You read all zeros, and there you go. 8.5 million systems later, you know you got a problem. So again, open questions, and I'm not sure whether we can change anything, but I think it's time to start thinking about it a little bit more.
Yeah, I think DevOps, where you're...
I will show something, but I just found it.
Yeah, we're talking about DevOps. That's a good place for people to make sure that if they're deploying a system, that they're developing and testing in the same operational environment they're going to deploy to. And if you take that one step further, you can do DevSecOps, where you add security in there as well. I don't know how many system developers are doing that. I know on the DoD side, or DOW side now of the US government, there is a lot of talk about DevSecOps, and they're doing that for their systems, and I think it's good if we do that for our systems as well.
I don't want to interrupt. I just want to show you what came to my mind, if this opens or not. But maybe you saw it, maybe not. But to me, the testing thing is, this is Buster Keaton. It's, 100 years old. But it's, you've certainly seen it or not. But it sounds like, and then you suddenly, what do you do with that? And of course, that's when you, let's say, avoid and the guy keeps doing it. So anyway, I'm not pretending to digress with this, but let's get back into Luca.
Yes. So one thing that Don was talking about before is about the system. I think you were talking about systems of systems. In that context, one thing that seems particularly tricky from my perspective is that the rate of change that happens in the system is seems to be accelerating, and that in that context, can AI help in the sense that AI can react more quickly than what a human organization can, but at the same time, I guess there is the aspect that often we don't understand certain answers that AI provides or how AI provides certain answers. So when it comes to use AI actively, because maybe we feel that we can use it actively because to defend from possible attacks. So what's your perspective and perspective of everyone with respect to this? I think it's going to be unavoidable because simply we say, well, we cannot do otherwise since this can be used to attack a system and provide an outage. So since it can be used as an attack, it has to be used also as a defense. Or do you say, no, this is problematic because we may not be able to understand and explain how it has been applied?
You've got two challenges with when you're talking about systems of systems. There is the intentional people trying to attack, and those things, there's always attack vectors that people are going to exploit, but that hopefully will be caught in your DevSecOps environment. You're testing for those security vulnerabilities, and of course you can't catch everything, but that's one type of attack. The other, which is probably harder to deal with, is the system is behaving in a normal way, but that normal way breaks another system. Mm-hmm. And the more systems that you have, the more ways that it can break. And I've done some of this type of work in my former DoD life, and I would say the more systems you keep adding, you just find more problems as you go.
Because you have a multiplicative effect of scenarios that you cannot anticipate at the same time.
Correct. And sometimes you're dealing with other companies that are building a system that you have to interact with, and they tell you they're going to do something, and then the system does something slightly different, and it breaks your system. And I do think AI could help. We didn't really have, we were talking about AI back in the day when I was doing that, but it wasn't as prevalent as it is now. So I think AI can understand a lot more states than a human can when they're designing these systems of systems. And I think that's going to be a huge help going forward. But again, I always come back to the trust. How much do you trust the answer when you don't even understand the answer that it's giving you? And so are you just going to allow it to give the operators notification that, hey, something might be going wrong? And maybe it should, again, I'm kind of leaning back on my former life. We talked about flexible autonomy a lot. Whatever systems we were building built in this idea of flexible autonomy so that you could turn autonomy up and down, where you say, I don't trust it at all. I want it to notify an operator every single time it's going to do something, and then allow the user to approve or not approve that autonomy action. Or they're somewhere in the middle, which is where I think you were mentioning, like the defensive part, where it does some defensive actions, but it doesn't do all of the things that it could do. And then there's that full autonomy. And do we ever get to the trust level? I don't know, because do you want it to be able to shut down the infrastructure because it found something that it thinks was going wrong?
Oh, there's someone who wants a question.
I was just going to comment on that, Ben. I'd say large organisations have this problem with intelligent agents already, that we call them humans. We've had issues with certain large vendors deleting tenants on us because someone has hit the wrong button somewhere in the organisation. And we sort of have these things already. You have delegations of what people can do, what people can't do. I guess an open question for me is what's different for the AI? We sort of had this discussion around regulation where we were sort of saying, does the AI need special regulation, or is it just regular regulation that needs to take account of AI? Is it the same in this case? Do you think we need some new tools that are fundamentally different somehow, or is this just a regular delegations problem that we already manage in large organizations?
That's a very nice question. So maybe we can have anyone on the panel who wants to say there about this, because this brings the human perspective versus the AI perspective that is in the back of our mind all the time. So.
I can tell you, a teacher, you give us homework.
I can tell you my take on this, but I want to keep it last, maybe. Huh? Well, my take, is detached from this. First of all, you brought a point that we build a system, and often the mistakes come from the fact that a human being makes a mistake, or maybe a sequence of mistakes. So we have to build a system robust with respect to that. And then the second aspect is like how AI can help. I think, and in this scenario, what's the difference between the AI and human beings? So I think one point that is we seem to it's possible that we agree is that AI helps you to do things at scale, in a scale that human being engineers cannot reach, both a scale in terms of space and time. But when it comes to what AI is becoming right now, is more like a mirror of how human organizations are to a certain extent. So in that sense, this may be the problematic part. I mean, human beings can do amazing things, and they also sometimes terrible mistakes, no?
Yeah.
But how much we're willing to accept.
Yeah, and the systems that I've designed in the past, or helped design in the past, we try to set up one way of doing things. So if an operator or user can start something, we set up a process where the autonomy could do the same thing, but it does the exact same way. So we don't have all these different ins and outs for the autonomy. It's the same in that a user can do, that's what the autonomy can do. And then you can basically give the rule checks to say, yes, I want you to go ahead and do X, Y, and Z, which is what the operator would have done anyway, or no, don't do X, Y, Z, just inform. But that's really case dependent on who's designing the systems, if they put that type of checks in there, or they just let AI run wild. But I think the way that way that I just described it makes more sense, and it's easier to understand, but I don't have access to every company to say, do it this way.
Oh, I like the idea to regulate the AI where you trust it more than in other cases. I think that's a very good approach. I just had to think of self-driving cars. Sure, that'll work fine on the 101 in California, but how long can it survive in Bangkok at rush hour? So that's where the level of trust is different in the same AI. So maybe that's something that we have to think about in general, but certainly in this case. Because I really think the big issue is that you can't just pull the plug on a running system. And you would like to then have like a simulator, but that's kind of impossible when you talk about systems of systems. I think that's too far-fetched.
I love self-regulating panels. But on that topic, that brought me memories about 10 years ago. I learned from an esteemed friend and colleague, Richard O'Keefe, about what's the safest code. And the safest code in his view is the one that has never been written. What's the safest system? Which has the largest amount of the safest code. Which brings me to something that happened on our days of the SKA, when at some stage, just a guy from the South Island like me started to ask a question, how deep can I go trusting things? Meaning, okay, how can I trust the operating system? How can I trust the BIOS? I mean, I'm not saying that I am not trusting, but why should I? And no one gave a damn about that question, and the answer that I got from extremely distinguished people, the vendor will take care of it. The vendor will take care of it. And that was at the end of 2016, and suddenly I got a Christmas present, which was called Meltdown and Spectre. Not sure if you remember that. A couple of vulnerabilities with pretty much all the Intel chips. So my Slack channel, when I ask those questions, suddenly become the most visited in the entire SKA, just because I just ask a common sense question. So I believe, and this is totally an entrepreneurial hunch, AI could have give a fastest, if not answer, at least prediction, because suddenly Intel went in damage control, dealing with, I don't remember the stats, but I mean it was 40% of the chips would be potentially affected on, I can't remember if it was the x86 or how. The fact is that no one remembers this anymore because, I mean, we survived that, and I probably was even less contentious that CrowdStrike, so I can't remember specific damage. But these two things stuck to me 10 years ago. One is like, oh, I don't want to be hacked, don't get connection. I mean, some people think that these are extreme measures, but we tend to forget the most basic measures. It's not that you don't need to wake up and go to the street because you're afraid that an asteroid will hit you. But there are certain basic measures that always you can keep them. And the other thing is the vendor will take care of it. It's that blind trust, which brings back to a comment a minute ago. I mean, the human condition, the human nature is a little bit naive, or we tend to forget the common sense. So, DK, you work with humans and machines. Who do you trust more?
I mean, if I would have known the answer, I will not be here. Right? I will be a billionaire or a trillionaire. No, it is a very complex thing. I mean, I think as the field is advancing, the more and more we are knowing what are the limitations of AI or what it can do. So I think it will take quite a lot, many years for us to really understand this human AI teaming and how we can do it in a robust manner. But I'd like to mention one thing, I think, which has not been touched in this panel. Here we are talking about AI for infrastructure robustness. But there is a big challenge people are facing, infrastructure robustness for AI.
Correct.
Okay? So if you think of AI, I mean, whatever we are listening, every time AI is based on some model. Model has to be trained on some data. So now if you see, that is the biggest problem the community is facing when people are talking about, yeah, I'll be taking, training these for 6 months, 8 months, or millions GPUs. Those systems are continuously failing because of the GPUs are commodity in nature. If you go and talk to any of these OpenAI, Facebook and all, they have dedicated team, almost like babysitting these training jobs. So I think we need to solve that first. And of course, the standard techniques being used there are the traditional checkpoint restart. It has been there in the field for many years. Of course, software infrastructure, people are coming up with better and better solution so that the checkpoint restart duration can be extended so that you are not wasting a lot of cycles for doing the checkpoint. So I think it is a cycle. As you can see, infrastructure for robustness for AI, AI for robustness. We need to remain in that cycle for some time. And if we can solve one, then it will move to the other.
I strongly believe that panels not necessarily need to reach a conclusion, but what are we necessarily going towards here? Because I mean, I want to highlight that AI is still a wonderful revolution, or is a fantastic achievement, or what, I mean, sometimes we tend to focus on the negatives, which are non-negligible, but do we actually believe that we can solve these problems using the right AI and the right conditions? And if so, which will be those conditions? Should we trust Claude instead of Perplexity? Should we rely on Copilot because the vendor tells me that this is the best solution? What do we do, Don Christie?
Okay. Well, you asked a question about humans versus machines. That's not the issue. The issue is whether something is open, transparent, auditable, easy for anyone to look into and assess, whether it's a statistician or some of the other scientists here or yourself. And that's how you build trust in the machines, the humans, and the models. And if you can't do that, why would you trust them? I don't know if anyone's read, there's a really good book called The Unresponsibility Machine. Anyone read that? We should all read that book. It's kind of about how people like myself have created this digital universe that allows organizations and individuals to not be responsible for activities that they would otherwise in their organizations be responsible for and possibly go to jail, whether it's the GFC, whether it's the taking out of airports, or even just saying it's the vendor's responsibility, which is kind of how we see a lot of IT play in large corporates and government. Everyone, even if XYZ virus scanner is not the best out there, the fact that everyone is using it, whether it's CrowdStrike or MS Defender or whatever, makes you, the individual, irresponsible. You don't have to be responsible for that decision. And so, I would argue it always comes down to transparency, openness, and auditability. So don't get into is Claude more trustworthy than something else? I was just reading an article about 20 minutes ago about somebody that's discovered a vulnerability in an open source stack. The code was submitted to GitHub by Claude, and that same code has been submitted by Claude into many open source projects in the last month. In fact, 5% of open source contributions to GitHub have come from Claude. Currently the best coding engine out there, apparently. So unless you can look into that and audit that and see that, then you shouldn't trust it.
I agree with what you say, but I still find it funny that we have a lot of talk about, do we trust AI, but then a lot of society will watch a video and believe anything that they see. But I agree with what you say. We do need that transparency.
Yeah.
So, this is not getting as contentious as I expected. So, should we go for drinks?
Yes.
Please do. Let's join me in saying thank you to the panelists.